we recording? There we go. We're recording. We're ready to go. Ready to rock. All right. Well, whatever math we'll do. Try to remember to move the camera around, and I'll give this to y'all too. We're recording, right? Yeah. Little red blinky light. Okay, good. Let me give y'all a warm up. This is our last class, right? This is week 11. No, it's not. We have Tuesday. We have Thursday. Yeah. So today we're going to do the kitten lab. After we do a warm up, we got a kitten lab. I have my shirt on. We have the kitten lab to do today, then the kitten homework. This is your last homework today for sure. I'm not going to give you homework on Thursday because I'm not going to see you again until your exam next week. And then Thursday we have a scavenger hunt to do, which is also a lab. It's
like a real one?
A real one.
Outside?
Well, you're going to stay inside, but yes, because I wasn't sure about the weather.
Okay.
I wasn't sure if the weather would be shitty or nice, so I made it inside. So, okay, so you may have even seen some of the envelopes as you walk through. Sorry. So.
What is that?
Don't you worry. It's going to be great.
When?
Thursday.
Okay.
Yeah. So we got lab today. I know we didn't do much of the notes on Tuesday of last week, and that's okay. Because as I was looking at the lab for today, I realized that anything that's important from the notes, we'll do in the lab together. And the lab I can give you points for. And the notes I can't. So I'm like, well, we'll just do it in the lab. So yay us. What else? Yeah, one last homework, Romeo the Kitten homework. And then the scavenger hunt on Thursday. And then the exam is Tuesday, right? Tuesday, yes, Tuesday. I think it's 8 a.m. again. So that's not a class.
Wait, do we get a partner like last time?
Yeah, partner and then individual. We're going to split it halfway, just like last time. Partner you up for half of it and then split you and have you do the individual part at the end. Yeah, exactly the same as last time. I think that worked pretty well. And of course, you can also choose to work individually if you want to. You don't have to partner if you don't want to. I'll give you that option, of course. So, cool. Don't forget the take home. Take home's still sitting out there waiting for you to. Well, I gave it to you, right?
Yeah.
Don't let that sneak up on you for Tuesday. Make sure you have that when you come in. Yeah, yours is in the pile. I just keep not turning it back to you. So it's always in the pile, Dylan, and it's actually I gotta go in my office and get it while you're doing the work right now. Oh, I've got it. It always makes me nervous because you're like, I'm kidding. You were like 5 minutes ago giving it to me already and forget it, and then I'm like, and the pressure's on me to not lose it. Shit. All right. Here. No, wrong. I made a better version. I'll be right back. I printed it yesterday. I gave Jessica the wrong one. Here's a better one. That same t-shirt. Love that. Exact same one. Everything okay? Okay. Here you go, fam. Oh my god. Ass. Gluteus essimus. Like a 10-year-old. What the hell is that? You kidding me right now?
Yeah, isn't that pretty?
It's so gorgeous.
I know, it's patchy.
That totally is. That's South Sister back there.
Yeah.
All right.
Can't
So
believe we live here, honestly.
I know. It's yeah. I'm telling you. So what you're looking at right here, real quick, I'm going to give you a heads up what you're looking at, and then I'm going to set you loose on the warm up so I can return papers and get you going. So Mauna Loa is a big old mountain down on the island of Hawaii in the state of Hawaii, and it's got an observatory at the very top, 13,700 feet in the air, I think. And one of the things that observatory does up there is collect CO2 data that as it's going by the top of the mountain, and it's been doing it since 1958. This is the most recent snapshot. I took it on Sunday afternoon. This is a snapshot of the CO2 data that has happened since 2019.
It's going off.
Oh, is it really? Is it erupting?
Yeah. Is that the one that looks like the eyeballs? I don't know. I like that.
I'll Google it. Yeah.
Oh, yeah.
Oh, like the actual,
I
yeah.
sound like a
My
mother-in-law.
So cool. Oh, I know. It's great. I want to get to the island of Hawaii, the big island one of these days. So what you're seeing here, there's two graphs, but they're showing the same thing. One The red one is the one we're not gonna be using today. I couldn't take it off though, I had to get photographs. The red one is CO2 levels as they literally are as the seasons change, and the black line is what they call a seasonalized CO2 level. Now, let me just, you don't have to understand why, but I want to explain it to you because I think it's kind of cool actually. When you look at this graph, I'm going to put it up on the screen so you can see it together. How many years are represented on the axis, dear friends? Or how long a span of time, I should say. 5 years. Thank you, Tommy. 5 years, Fred. Now, I know some of you might get confused by that because you see 6 numbers, but listen, I wish Jessica was here. I'm going to give you a shout out on film, Jess. There are 6 numbers, right? 2019, 2020, 21, 22, 23, 24. But there's only 5 years between them. Think of a fence post. Same thing as a fence post again. So, let's pull this up real quick. Loa, there you are. There she comes. There you are. Okay. So, there's 5 years of data, and there also is 5, like 2019 is here, right? And then it comes back at 2020. And then it comes back at 2021. Any idea? I think this is one of the coolest things when I look at the graph. What causes the CO2 levels to rise and then drop through the year? You say it. You say it. You say it. Is it that? You say it.
No, I can't say it.
Sure?
Yeah.
Does it start with P
No.
and end with Lance?
Yeah.
Starts with P, ends with Lance.
Well,
Plants.
yeah.
When plants are active, like spring to summer, they absorb. You're gonna say seasons. It's exactly right. It's exactly right. It's the seasons. You totally knew it.
Oh.
It's the seasons. As the plants get more active, they absorb more CO2, and as they become dormant, they absorb less CO2. Isn't that cool? Totally nailed it, dude. Totally nailed it. I love it. Okay. So, but that's tricky to look at because we've been dealing with lines in the past couple days. So what they did on the black one here is they seasonalized it. They took out the extremes and said, and they took the effect of the plants and the seasons out. So it's just, now do you agree, fam, that it looks like that's pretty much a straight line going from left to right, if you ignore the red. It's not perfect because it pops up, pops down, pops up, pops down, but it looks like it's pretty much marching kind of like that, yeah? Your first job on the warm-up is to figure out the slope of that line based on the numbers that are on the graph. Now let's talk about the numbers on the graph real quick. I know, I'm an ogre. Friggin' ogre I am. Look at the numbers on the graph, fam. Tommy has already been kind enough to give us the horizontal numbers, which are the 5 years. Beautiful. Now, I'm asking you for a slope, right? Real quick review. Slope is what? Thank you, Tommy. Must be in my office. Rise over run. So we know what the run is now. It's 5 years. Your job is to find the rise. Now, the unit on the rise is interesting. It's something that comes up a lot in climate science. Take a look at the vertical axis. The numbers start at 408 and go to 424. Do you know what those numbers represent? Turn your head sideways and look at the label and see if you've ever heard that before. Oh, that's the one you wanted. Yeah. Take a look. Turn your head sideways and read that. You look at CO2, mole fraction, ppm. You know what ppm stands for? Parts per million. So we're talking about in a million parts of air, how many parts are CO2? And this is climate science. A lot of it is measuring CO2 concentration in the air. And one of the warnings climate scientists have given us is that if CO2 levels get high enough, it can be dangerous. I don't want to talk about that today because actually it's a little bit convoluted depending on which source you look at. I just want to measure the slope and see how it's been changing over the past 5 years. Okay? Go get it. And then question 2, I think, is the fun one because I think their graph kind of sucks even though it's pretty. Okay, let me read your papers and some markers. So if anybody needs any dehydrated apples or little tiny tangerine cuties, help yourself. These are from our tree out in our backyard. Hey, get in there. Get in there, honey. They're a little chewy, but they're still pretty good. They're good. Yeah, apple.
I wanna try it now that you're here.
Jam apple. Yeah, you met. Yeah. A little chewy. What I do? Put them in a Ziploc for a month now. A little chewy. A little chewy.
Thank you.
A little chewy. Like a fruit roll up, but. Yeah, go ahead and get it.
Wow, they're really sweet.
I know, right? Well,
I started like eating it.
I like sharing my food. Yeah, baby, get in there. Yeah, get that cutie. Yeah, get some of those too, of course. Yeah. These are hollow red apples. They're super sweet. You leave them on. You leave them on once the first couple frosts happen. Really sweet. I think they get scared and they start pumping sugar to the fruit.
Wow.
But now, hello. Sorry, bro. Sorry, Jessica. I'll sing you some. I always think that's a Tesla shirt you're wearing. Remember the rock band Tesla?
Yeah.
It looks like their logo so much.
It does.
Equally amazing.
Literally
In a
like
different
that
way.
funny
What's that?
Such a warm movie.
Oh yeah, dude. Got your camera right there on top, so I don't lose it. Got your camera right there on top, so I don't lose it. Put the pile, so I don't lose it. Turn it off spit. Perfect. Ready? You're welcome. Remember, it's important to know this. I had migraine once. I have a lot of respect for anybody that has to fight those things routinely. Stuff separated here. I apologize. Oh, I like what you're seeing. I like what I'm hearing back there, Tommy.
The brain ain't braining right now.
Your brain ain't braining?
No.
That's okay.
My brain's not braining.
We're braining. All right, it's a little early. You're welcome. Let me know if any of the oranges. Every once in a while, a bad one gets it. We buy them in those big bags, and sometimes a bad one gets in. So if you need another one, you can swap it out for the less one in here. What you got, Nick? The black one, not the red one. Although the red and the black are going to get you similar answers, I think the black one's easier to deal with. Because the black one. Well, let's talk about that number one, yeah? All right, so the black line goes like. That's a little bit low. Isn't it? Let me draw that back.
It was a good start.
It was well.
I was trying to be a good one.
I've done better.
Start at the top and go backwards.
Bring it in.
Oh,
Should be
you're
done.
already still at old school.
Old school. ICIA. Not quite perfect, but it'll do.
There we are.
Not bad, not bad. Okay, fam. There's the line we gotta calculate the slope of. Okay. So Tommy has been good enough to already give us the run. Appreciate you. Let's not use orange because that's already red. So the run, yeah, get some, baby. They're not bad, huh? They're kind of like candy. Sorry. I'm worried if you just don't push so hard. It won't squeal. Tommy's already given us the length of that line. And it is 5 years. Yeah, it's 5 years, absolutely. 5 years. Awesome. The only thing we gotta figure out now, that's the run. That's the run. All you gotta figure out now is the rise, how much it's going up. And this is where the lab's gonna come in today. We're gonna play with kitten weights in this. That. So, what's that? What do you think, Dylan? Give me some ideas, babe. Well, oh, good. That's actually 100% correct. And that's what I think is kind of interesting about this graph. Like, you've got that one there, right? So let's talk about that point right there.
That one, I did this
3 what?
413.
Wouldn't 413 be up here, brother man?
Or
Wouldn't that be 413? Between 12 and 14? Does that make sense? I think I heard you say something, they go by twos. I heard you say that earlier, and that's exactly what's going on. Those 400 numbers do go by twos. So like this 410 jumps 2 to 412, jumps 2 to 14, and so forth and so on. That's 100% correct. That's one of the reasons this graph is a little bit tricky to look at. So let's talk about this point right here. What's that point? Oh, I like that. And Mariah, I think 10 and a half. Is that what you said? 410 and a half?
Yeah.
I like that. This starting point right here. It looks like it's right about there, yeah? And then that one we gotta talk about, because that one, this is what Dylan was talking about as far as subdivisions, right? The problem is it's between 410 and 412. Is it at 411? Doesn't look like it's quite at 411, does it? Looks like it's somewhere between 410 and 411. So I like 410.75. That's cool. I like 410 and a half. I think that's cool. Anybody have any strong feelings either way about it? No? 8 o'clock. 8 o'clock. I'm killing you. Killing you. Okay, let's call it 410 and a half. No disrespect. Or 410.75, Tommy. Whatever you want to do. It's exactly. It's a more round number, and also we don't have that kind of laser precision that we need. I mean, we can pull the raw data down from the observatory if we need to. I'm just trying to get you ballpark it. Let's do the same thing for the top one. Now this one's up here, yeah? Now this one's a little bit trickier, but I learned something yesterday in Redmond when I was looking at this graph on the screen. They didn't bring the labels over to this side, but they did put the dots on that side, which is kind of nice. So we can kind of get see that 424 up there? That little extra long line there is also a 424. That's kind of nice. They're doing us a favor by doing that. That 422 is this one right here. So what do you think this dot is right here, fam? I like that. How about 422 and a half? Especially if you were to continue it onward to actually get all the way to 2024. I definitely think it looks like it hits 422 and a half. So I like that. 422 and a half. So if in 2019 it was 410 and a half parts per million, and in 2024 it was 422 and a half parts per million, when did it rise in that time? It's not far from 9, Dylan. About 12, yeah? About 12 parts per million. Not far from 9. What's that, brother? Okay, but it's 8 o'clock in the morning, man. 8 o'clock in the morning. And this is me. You have to be honest. It's a mean warm up. I just like the graphic. I thought it was cool. Plus I love the light, so it's fun to see the data from the volcano. So that looks like it's going up 12 parts per million in 5 years. So what's the slope of that line? About 2, yeah. 2.4. You're feeling saucy? How'd you get 2? You're right. Divide 12 by 5, and isn't that 2. I'm gonna go with 2.4. If that's okay. I'm feeling saucy today. So, Hillary, you buy that? Let's do this. Let's do it. Let's do it. Let's do it. Tommy, rise over run. Right? Yeah. Rise divided by run. Yes? Okay. The rise, 12 parts per million. The run, 5 years.
Oh my God.
Oh, if it was 6 years, it would be exactly 2, wouldn't it? Yeah. I know why you thought it was 6. Burton, if Denise was taking new year. But the year itself is the time between the posts. So 6 posts equals 1, 2, 3, 4, 5 years. Time is weird. Time screws with us in that way. This is why Y2K happens. So, only 5 total years of time. Awesome. 12 ppms. What's 12 divided by 5? There's your 2.4. And what's the unit, dear friends? 2.4? Oh, say that again. That is friggin' awesome, Ryan. Is that you? Thank you. Appreciate you. It's a fun unit. Parts per million per year. It's got 2 pers. Where are my medical students? Where are my nurses and my medical assistants? Yeah, get ready for this kind of stuff. I just taught on Sunday, I taught the Farm Tech kids, down Health Careers. They were doing allegations and drip rates and drop factors and things. And the unit that kept coming up was things like, we have to give a patient 5 milligrams per kilogram of body weight per day, like double pers. Because there's 2 things going on in there. You got to measure their body weight and dose them for their weight, but then you also have to dose them in a regular interval. So the per that Mariah just said, although it's carbon dioxide here, can also apply to things like drugs, drug dosing, and things like that. Hello, Avery.
Hi.
All right, dear friends. So that was fun. We got the slope. Now, if we take a look at the graph there, that line. See, doesn't it seem steeper than 2.4? I mean, 2.4 is a pretty small number, yeah? I like Hillary's, I like that face you just made because it's all relative. Like, it could be really steep compared to something like 1. But what do you think, Burton?
Well, that's what I was going to ask you. Because some people would consider like a really steep slope to be a 1.
Yep.
And some might say, oh no, a steep slope is a high number, like a 9 or a 12.
Sure.
Well, how do you define your unit?
I'm not going to, not because I'm an asshole, although I am, but because that question is, I love that question, first of all. Well, because here's a way to prove that 1, that you just said, which I love, by the way, I can prove to you that 1 is a steep slope. Ready for this? Give me at the top of the ski slope. 45-degree angle. Just me with my poles. My 2. Okay, get ready to go down 45-degree angle ski slope at Hoodoo. Which I don't even think Hoodoo has. Yeah, I think that one up front. Oh, no, that's not even 45 degrees. That might be 45 in places. This is incredibly steep, and it's got a slope of 1 because the rise of a 45-degree angle is the same as the run. Because if you divide, I wrote the same rise. If you divide the rise by the run and get 1, that's a slope of 1. That only happens to have a 45-degree angle. That's an extraordinarily steep angle. I think maybe the summit of Bachelor, like not under the lift, but off to the right side, is probably that steep. Yeah, it's probably even steeper than that, I would bet. Is it steeper than 45? There we go. You would know because you're ski rescue, exactly, man. So 49. So that's incredibly steep. So good point, Burton. Absolutely good point. Let me ask it a different way. These are parts per million, right? So of a million parts of something, this is where I'm building actually a life-size model on campus over the next couple of years of a part per 1,000, a part per million, a part per billion, so you can actually see what it looks like. A part per million is small. You have a million of something, and one of them is a CO2 lake. If you go up by 2 a year, how much of a difference is that actually making? Right, that's what I was getting at. That's what I was getting at. But doesn't that line make it seem very, like, it's happening really quickly? So I asked them how they did that. The graph is not wrong. The graph is not wrong. It's just created in such a way to make it look exaggerated. And Mary has a good theory. Say it again, Mary? Yes, it's zoomed in. How so zoomed in, if you don't mind me asking? Nailed it! Nailed it, Mary. It's the vertical axis they've zoomed in on. Take a look at the backside of it. I redid the graph for you in Excel on the backside. Same exact graph. Same exact graph on the back. Looks a little different, doesn't it? That's the same data. Yes! This or this? This one here? Actually, both, you're right. You're absolutely right, Dylan. Both of them. It's how you look at both of them. Stock graphs will often do this thing. It's called truncating the y-axis or zooming in. I like zooming in better. That's so much better. Now I can actually show you here real quick. Let me do a little bit of ghetto editing up here real quick. Hang on. So if I take Mary, I love that you said that. So this data right here is exactly the same. Let's see if I can do this. I wasn't planning on doing this, but because you said what you said. Let's see if I can do this, my dear friend. I'm gonna put that here. Okay. Now, if you look at that, you can see. You take a look at that, you can kind of see the little wiggles and wobbles in it, can't you? Select just that. See if I can get this to work. See if I can make it look like the front. And then if I stretch it down. Oh no, that didn't work. If I can test my ghetto skills. I would have hell with it. Don't let me do it. I was hoping to do exactly what you said to do, Mayor. Stretch it. But it is. It zoomed in. It zoomed in on just that one little section. So they're ignoring everything that starts at 0 up to 410 and only focusing on where the change happens. Well, if you're only focusing on where the change happens, it's going to look like a huge change. For example, if I start in the middle of this square and I move to that line, that's not a very big change. But if I focus in on just this and blow that up to a large picture, it's going to look like a big change. So this whole, oh, not this one, this is a good one. On the front here, by zooming in on only the 410 or 408 through 424, they're making a small change look much bigger. I mean, hell, if you think about it. Think about it back to the original graph. Why did my mouse come? Oh, there you go. This graph here. This point right here, dear friends, looks half as high as this one. This one looks twice as high as this one, doesn't it? Twice as high. But this one is 416, and this one's 422. That's not twice as high. That's only 6 more. But by cutting off all the stuff on the bottom, you lose that. You make it look. Journalism, this is an important one. Serena, this is an important one. I see this all the time in published graphs. As a matter of fact, when I drop the data into Excel to make this graph on the back for you, it made that graph first. It immediately shortened the y-axis. Probably because they don't think people want to see all that blank space. Which is fine as long as you understand the blank space is there. But a lot of people will look at that and go, oh my God, we're going to die next year! Which is maybe the intended effect, I don't know.
You might.
We might. Maybe not by CO2. I don't think it's going to be from CO2 overload. There's always that possibility, exactly. I don't think it's going to be CO2.
That's just like.
It's Mauna Loa. It's 13,700 feet in the air. So it's measuring atmospheric CO2. It's actually a really good indicator of atmospheric CO2 because it's so far up in the, I think it's stratosphere, 13.7. I don't even know if that's the right word. But it's in the, it's high enough up. Do you know there's snow on that mountain year round? In Hawaii, there's snow on Mauna Loa. You can ski it. One of my bucket lists is to take my bike to Hawaii, dip it in the Pacific Ocean, then ride to the summit and ski part of it. One of these days. I can't surf. My wife can surf. She'll surf. I'll bike. She'll climb up to the top like a sensible human being. How much more? 12,000. Oh, I got it. See you next week. Cool? Awesome. I thought so. Thank you. Appreciate you. All right. So we'll do that. Now we're going to move to something that has nothing to do with volcanoes. Actually, I just lied to you. One of these kittens' names actually does have something to do with a volcano, which is hilarious. Max named these kittens. I know. They're just the cutest. They're the cutest. So I forgot if I asked you, did anybody ever foster kittens in here? You have Avery. So much fun. How many did you have at a time? Do you remember? Oh my God, 12.
I had a whole litter at
That's a
once.
lot of kitten poop.
I'm a foster failure.
You're a foster fit and you kept it. Yeah.
2 of those
Trust
were
me.
foster failures.
Trust me. Trust me, I was we were extraordinarily close. These are hard to get back. The last batch we had were 2 kittens and their mom, and mom was a Siamese calico. coolest cat I've ever seen in my life, and she took no shit from our cats. She got out of the bedroom with the kitten for him once, and our cat came, Murphy came up to her, "Rawr," and she just looked at him and went, poof. Sent him ass over tea kettle. He ran in the bedroom. I never saw him again for days. I wanted to keep her so bad. She was so freaking cool. What's her name? Willow? Oh, you keep both. You keep both. Sorry, keep both. Keep both of these. Yeah, I didn't get a chance to staple them yet, so we'll staple them later. Both of these pages are for you. This is our lab for today. You guys got it? Okay, good. Okay, so now, do we need more? No, we're good. And we'll get to the sheet in a second for sure. I may have to open it up. I don't think it's there yet. We're gonna need a Google Sheet for today. I think I forgot to turn it on because I'm Canvas challenged. But real quick, fostering kittens is fun. You pick them up from the Humane Society or Brightside or wherever you foster them for. You bring them home. They're like 3 or 4 weeks old. They're adorable. They look like this. These are our first 3. That's my wife holding them. That's Paulina, Stella, and Romeo. They were tricky at first to tell Paulina and Romeo apart, but Paulina had that little goatee on her chin, which is super cute. Stella was easy. She was jet black. And there's Romeo with his big eyes, his little tiny nose. Very cute. Max named them all. Our second batch of fosters, I lost track of how many we've done now. Doesn't matter. So you keep them for a while and then you give them back. So we heard foster failure. Sometimes you don't give them back. Has anybody fostered dogs before? We got some. Okay, you have Alo. Okay, Hannah has. Good. And when do you give them back? Do you remember? You kept them for a while? Okay, for about 3 months. Gotcha. Avery, how long did you keep your puppies?
I kept my cats like 2-3 months.
Cats 2-3 months. Awesome. Who else has fostered Alo? You fostered?
Kept 2 of them.
How long did you have your critters? Were they dogs or cats? Dogs, and you had them for?
3 months.
About 3 months? Okay, awesome. Now what I'm going to do, dear friends, we're going to come back to that question I just asked in a second. I got to get in, and I got to get into Canvas and turn the damn spreadsheet that we need on. I forgot to turn it on. So give me a sec. Get into Canvas, though. I want to get in here, too. Turn this thing on. I'm going to get you start working on it.
Oh my god, are you master staffing?
All right. Then,
Really?
modules. Give me 1 second. Go to week 11 in Canvas, and then I'm going to have to move it. Kitten Lab. Here we go. Move it to week 11.
Probably.
I know, I can't either.
This is
No,
my
that kid's
side
like
channel.
my age.
Okay, dear friends, it's there now.
I'm assuming that one.
Week 11. Does anybody need a laptop today?
What's it called?
It's called the Sheet for Kitten Weights Lab. You might have to refresh because I just turned it on, Hillary.
Okay.
Anybody need a laptop? Or are we good? You can also share it.
If it is, they did a bad job.
I
making
was
it.
there. Well, I was about to say. There. Okay, I was about to say.
I gotta get on to 97 all the way to the laptop.
I don't know that's far of a critter. I think I am, but like, I have one.
What I'm going to share with you, dear friends, is one of the things you have to do when you foster kittens, at least the folks we fostered them for. We have had to, they give you the kitten, which is in this case, and they give you a little baking scale. And they say, weigh these damn cats every day. Cool. So you have to put these little kittens on a baking scale and take their pound weight. So here's the first 7 days of the weight gains for Paulina, column 1, Romeo, column 2, Stella, column 3. Take a look at that, dear friends. Anything jump out at you?
A pound.
A pound.
That's so small.
I know, they're tiny. Look at them. They're little. They're cuter than hell.
Romeo lost weight.
They're so cute. Say that again.
Romeo lost weight.
Couple things. First of all, they're tiny.